Hi everyone, this is Supply Chain Management and Logistics. In the last class, I explained how to determine the safety stock amount based on the specific cycle service level. In order to explain the relationship between the safety stock and cycle service level, I mentioned about the reorder point under the continuous review system. I believe it's the time to talk about the continuous review system and periodic review system and what's their differences. Okay, let me get my note here. Okay, so today's issue about the continuous review system and periodic review system. That is the differentiation policies in regarding the inventory control. Okay, so here's the impact of the replenishment policies on safety stock. So basically, this is about the how to determine the safety stock based on under the replenishment policy. That is the either continuous review system or the periodic review system. Probably you already remember that is the difference between the continuous review system and periodic review system. Yeah, this is just a two type of inventory control system. We classify any inventory control system into these two different types in terms of how to watch over the inventory as time goes on. Basically, under the continuous review system, we keep watching the inventory as time goes on. We never lose a sight on the inventory. So anytime under the continuous review system, you know exactly how much inventory you have in your warehouse. But on the other hand, under the periodic review system, you don't keep watching the inventory over the time. Just time to time, you just drop by the warehouse, and only that time you check out your inventory, and that's the periodic review system. So basically, under the periodic review system, you are not able to know how much inventory you have between your until the next visit your the warehouses. So reason why we classify any inventory control system into either the continuous review system or periodic review system because depending on whether we use a continuous review system or periodic review system, the way we determine the make the two important decisions that are under any inventory control system, that is, when to order and how much to order, can be very different, okay? So basically, under the continuous review system, where you decided when to order and how much to order is quite different from the view under the periodic review system. Let's start with the continuous review system first. So under the continuous review system, if I give you a conclusion first, that is, under the continuous review system, the way you decided how much to order is order quantity. That is, you using just a fixed order quantity, just like EOQ. Okay. So whenever you decided how much to order under the continuous review system, you order exactly the same amount. So you don't have to always use the EOQ, but mostly we use just a EOQ. Okay, just a fixed amount of the order. Okay. But on the other hand, because you just fixed the amount of order every time, so question is, how could you handle the uncertainty of demand? Yeah, only by using this fixed amount of order, you are not able to cover the uncertainty of demand. You need the flexibility in somewhere other than the just the order quantity. So in fact, when to order, that is, you use so-called under the continuous delivery system, so-called reorder point. I already mentioned the many times before. Okay, so what is a reorder point? Reorder point is not just showing that it's not about the hour or week. It's not a time. It didn't specify a time. In fact, this is about the inventory level. Okay. So reorder point, that means, such as let's say reorder point is 100 unit. That means under the continuous delivery system, as I said before, okay, that is you keep watching your inventory. So just imagine that under the continuous delivery system, you keep watching your inventory as time goes on. When you find out your inventory level is exactly same with the 100 unit, there is a reorder point you already set, then that tells you that's time to order. Okay, so do not misunderstand. Reorder point doesn't tell you exact time, that is as a hour or year or month. No, not at all. Okay, this is just one of the inventory level that tells you when you have to order. That is about the reorder point. Okay, so as I said, when we decided how much to order under the continuous delivery system, you just set the fixed amount of order. Okay, no, usually EOQ. So that way you are not able to cover the uncertainty of demand. You need a flexibility. Okay, so the way you get the flexibility is when you decided when to order, especially when you decided reorder point. Okay, how come? By considering two things, that is the service level and also the lead time. Okay, so let me get that right, how we can decide it. That the EOQ we already handled, that is all you have to just the following the classical classic EOQ formula. Okay, so let me concentrate on how to determine the reorder point. Okay, the way we decided the reorder point is just the average demand during the daytime. Again, here, the assumption is demand is uncertain. So only way we specify demand is either using the mean and standard deviation. So that's why here I didn't mention as a demand. Why? Because we are not able to specify demand as just a one number. We can only tell about the mean of demand, okay? And plus and safety stock. So reason why we have to concern about the demand during the daytime. Let me tell that explain about that in the later in details. Okay. But anyhow, thing is, the way you set the reorder point is you have to add the safety stock to the average demand during the daytime. Why not only the average during the daytime? Because it's not safe. Okay, why? Because if you hold just only the average demand during the daytime, just average, then it's going to about the 50% that you are not able to provide a service to your customer by using available product in your warehouse. Okay, so that's not enough. Why? Because in this situation, we assumes that more realistic assumption. What is that? The demand is uncertain. So that's why just by having the reorder point is actually same with the average demand during the daytime is not enough. So we need to add something that is a safety stock to anticipate it and also cover the demand uncertainty. Okay. So before I showed you that how to determine the safety stock amount. So let me show you what happened to the inventory level over the time under the continuous review system by drawing some graph here. You remember that is I draw this kind of graph, okay? That when I showed you what happened to the inventory level under the EOQ, okay? So still, this is the inventory, on-hand inventory. And this is the time, okay? So at this time, what I have to show you is what happened to the inventory in your warehouse if I apply the continuous review system. So first of all, let's say I have a certain amount of inventory already. Sorry. Like this. Okay. Then that's the starting point at the time 0. And as time goes on, of course, demands happens. So the inventory level will decrease. But question is how? How the inventory decreases as time goes on. Is it just a straight line like a EOQ? No. Under the EOQ, the reason why that is inventory level is the decreasing in a straight line only because one of the assumption, what is that? Demand is a constant, okay? But on the other hand, under this situation, I would rather have a more realistic assumption is demand is not constant. Of course, it's not certain. It's uncertain. Demand is uncertain and is very fluctuated as time goes on, okay? So it's not a straight line, unlikely. So most likely is look like this. Sometimes it's just a decrease small amount, but sometimes it's drop very fast like that, okay? It's like a irregular form, okay? But on the other, as I said, okay, under the continuous review system, you have to set the real point for first before even starting this the inventory, the drawing the inventory level, okay, as time goes on, okay? So let's say you have, let me just, this is a real point. I already set before even start drawing this inventory level, okay, at the time 0, okay? Then still, let's say this is the inventory real point, okay? Then let's start at the beginning again. Okay, inventory level is decreasing irregularly because demand is not constant and also uncertain. And also is then I keep what, but under the continuous review system, I'm supposed to keep watching my inventory as time goes on. And then I just keep waiting until the inventory level hit the real point. Then inventory level hit exactly same in the real point. That's the time when I have to order, okay? But on the other hand, I cannot receive the ordered product right away, okay, when I place order. Why? Because at this time, not like a EOQ situation, I'm going to say that lead time is not a 0. If a lead time is 0, certainly there will be a big change on the inventory level, okay, once I place order. But at this time, I have to wait for the ordered products until the lead time is over, okay? So even though I placed order, then my product, some amount of product, there is a EOQ. Then when the inventory level hit the real point, but still the inventory level doesn't change at all. It's not increasing. It's changing actually still decreasing. Why? Because during the lead time, still the demand happenings, and then also the inventory level is supposed to decreasing. Okay, so until the lead time is over. Let's say this is a lead time. Then now I can receive that ordered product. How much? Let's say order lot size here is a Q, fixed amount. So how much is increases? The Q amount. Let's say this is a Q amount. Okay? And then continue. Because I have enough inventory over the real point, I don't have to place order again, okay? Until that I just keep watching. Again, inventory level hit the real point in another time. Then that's the time to order, right? So that's the time to order. But still, I cannot receive that ordered product right away. Why? Because I have to wait for a lead time to receive that ordered product, okay? So still during the lead time, the inventory level is still decreasing, okay? And then once the lead time is over, then I can receive that ordered product. That is how much? Yeah, I promised I'm gonna order exactly some amount. How much? The Q, okay? And then continue. During I'm over my watch, the inventory level is decreasing, and another time that inventory will hit the real point again, then I place order. And during that, the lead time, still the inventory level is decreasing. And then at last, the lead time is over. I can receive the ordered product. How much? The Q amount. Okay, and I keep continue like that. Okay. So this is what happened to the inventory level under the continuous review system. Okay. So let me mention about this first before I move to the next one. That is, what happened to the time between order? Okay, under this continuous review system. That is, let's say this is a time between order 1. First one, time between order 2, and time between order 3. Okay. So here that time between order this one, and time between order 2 is this one, and time between order 3 is this one. Okay. So my question is whether it's a first time between order and time between order second one and third one are same. No, actually it's not. Okay. I mean, by coincidence, it could be, but on the other hand, most likely it's not. Okay. They are not going to same. Why? Because the depends on that the demand. Okay, demand is uncertain because the time between order, when you place order, this could be very different. How could you decide when to place order? Yeah, based on the real point. Even though real point itself is a fixed, is the same over the time, but still because demand is uncertain. So that's why time between order could be very different, depends on the what? Demand uncertainty. Okay. So I can say this is a most likely it's just different. Okay, under the continuous review system. So let's find out how to determine the safety star under this situation. We already handled this, okay? But anyhow, let me just have this, okay? That is, let's say the D is the average demand per certain time period. Either could be monthly basis or weekly basis or daily basis, doesn't matter. And sigma D is standard deviation of the demand per certain period. Reason I specify this because demand is uncertain, okay? And let's say R is the lead time. Okay? And we already had this, but anyhow, the mean during demand during the lead time is just the, let's say DL is D multiplied by, sorry, it should be capital D. D multiplied by L. Okay? And then standard deviation of demand during the lead time is just the sigma L. That is sigma D multiplied by square root of L. Okay. Then what happened about the safety stock? We already had this, right? Safety stock amount is just the inverse, the standard normal distribution, normal distribution, cumulative normal distribution function of cycle service level and multiplied by sigma L. Okay, here is that we can say that is demand during the lead time is another random variable following the normal distribution of the mean is a DL and sigma L square is a variance. Okay, under this we can safety stock is just G multiplied by sigma L. So what is a G here? G is this is so-called number of the standard deviation. So where we can get this? Yeah, based on the given specific cycle service level, we can get this from the what? The standard normal distribution table. Okay, we already had this before. Okay, so let me show you the example, just a simple one. That is example. Okay, let's say G is 1.04. Okay, so according to that, real point become the average demand during the lead time plus 1.04 multiplied by sigma. I'm just using the previous formulas to show this, the real point, okay? Then under this situation, what is the cycle service level, okay? The cycle service level is just probability of demand in the lead time less than the DL, the real point, that is DL here, plus I'm just using this, okay? And plus 1.04 multiplied by sigma L, okay? That is just a real point. Okay. Then, because demand during real time is following the normal distribution, to get this probability, okay, or I have to just standardize it to use a standard normal distribution table, okay? That is become the G now is less than DL plus 1.04 and sigma L, that is a real point originally. And then from that minus, what should I do? DL average and divide by standard deviation, okay? So if you do that, what happens is G is less than just the 1.04, I'm sorry, it's 2, 1.04, okay? So according to so where I can get this probability, just take a look at the standard normalization table, okay? So take a look at that. 1.04, where is the 1.04? 1.0 here, and 1.0001, 03, 02, 03, and 04 here. That is 0.3508. 0.3508. Is that all? No. Again, that the standard normalization table we use starting from the 0. But on the other hand, this is about the starting minus infinite. So we have to add the 0.5. So that become 0.8508. Okay. So that means what? If the G value is 1.04, when we calculate the safety stock, then cycle service level become 85%. Okay. So here, cycle service level become about the 85%. Okay. On the other hand, as I explained before, this is the exact opposite way to be decided, design the inventory control system. Normally what happens is you specify this cycle service level. Based on that, you try to determine the proper amount of a safety stock. Okay. So, I mean, let's kind of give you the homework. That is, what about if, no, this is not homework. I'm just showing that here. If cycle service level 99%, then my question is, what's going to be G value, corresponding G value? That way I can calculate the safety stock amount. What's going to be? Or you have to take a look at the table. Which table? The standard notion table. So at this time, the way you look at the table is exactly opposite of the way we previously did. What is that? You looking at the inside of this, the probability and looking for the 0.99, the closest one to the 0.99 and try to find that corresponding G value. Take a look at that. Do we have a 0.99? Any close to that number, 0.99? No, we don't have. Why? Because this is again starting from the 0. So 99% when I mentioned cycle service level should be starting from the minus infinite. So you have to imagine that from this original, the probability from the table, I have to add the order 0.5, okay? So what I'm actually looking for is not 0.99, that's a 0.49, okay? So where's the closest one to the 0.49? Here is that, I can see that is this one, between the 0.4898 and 0.4901, okay? So I would later choose that 0.4901, that is a closure, okay? Then the 0.4898. So I can choose the corresponding G value, that is a 2.3, the 3, okay? So according to that, that is a what? 2.33, okay? And now I have to just what? According to that, the way you calculate the safety stock, that is just a real point, is just the average demand during the real time plus G value is 2.33 and multiplied by sigma L. This is a safety stock. And this is just a mean of demand during the daytime. That way I can easily get the real point to have a cycle service level is a 99%. Okay? And the EOQ is easy. All I have to just follow the classical EOQ formulas. Okay? I already used many times before. Okay? And then before we move to the periodic review system, let's find out what is the total cost under this system. Total system cost. If I apply the continuous review system, let's say this is annual in a year, how much you have to pay that the total cost under the continuous review system. Here is that we have a 3 portion, that is a cycle service cycle, the inventory holding cost as usual, plus the ordering cost. But there's another cost here. What is that? Yeah, not only the cycle inventory, we have the safety stock. So here's that we have to add the safety stock holding cost. Okay. And then the way we indicate, we indicated that this cost is formulas, that is just because I order exactly same amount with the EOQ every time. So EOQ divided by 2 give me a every cycle inventory level and multiplied by unit inventory holding cost plus annual demand divided by EOQ give me a order frequency in a year and multiplied by the unit ordering cost, that is give me the annual ordering cost plus the safety stock amount is what? Just a safety stock multiplied by H. So here's that I assume that I don't differentiate it. That either the cycle service level, cycle inventory or safety stock, when I calculate the inventory holding cost, it's actually same amount of cost I have to pay to hold either the cycle inventory or safety stock. Okay. So that's all about the continuous review system. Let's move to the another type of inventory control system. That is a periodic review system. So at this time, the big difference from the periodic from the continuous review system is what? We don't keep watching your inventory as time goes on. Just time to time you visit your warehouse and then you decided how much to order. Okay, that's the periodic review system. Okay, so if I give you the conclusion first, that is under the periodic review system, let me talk about when to order. Okay, because it's periodic, that means what? It's a kind of routine job to visit your warehouse and place order. So here's that. I assume that when I place order, when I visit my warehouse, that's the time I place order. Okay. So whenever you just drop by your warehouse, that's you have to order some amount. Okay. So that's why here I have a fixed interval reorder. Okay. So this is I fixed order period. Okay. So how can I decide that there's an order period? That is the normally that I use a EOQ. Okay. So how can I use the EOQ? That is, we already learned about this when I talk about the EOQ. What is that? Time between order. Time between order under the EOQ is just a EOQ divided by annual demand. That's all. Okay. That simple calculations give me then when to order under the period review system. But you remember, that is, under the continuous review system, what I fixed is what? Order quantity, not a period. Okay? But on the other again, under the period review system, I have another problem. What is that? Because I have a fixed the order period. So I don't have enough flexibility to handle the demand uncertainty by only having just a when to order. Okay? So what should I do? Yeah, when I decided how much to order, I'm going to kind of consider the flexibility to handle the demand uncertainty here. Okay. So under the periodic review system, the way you decided how much to order is so-called the target inventory level. So what is a target inventory level? Target inventory level, again, this is the inventory level, okay? But at this time, the way you decided how much total is like this, okay? So again, under the PDDB system, you don't keep watching your inventory as time goes on. You just drop by your warehouse and you check your inventory and you just place order, okay? But how come? That is, let's say target inventory level is 100 unit, then in the next visit, it's a time to visit your warehouse, and then you visit your warehouse, and then you'll find out your inventory level is just a 20 unit. Then how much you have to order? You have to order from current inventory level 20 to the up to the target inventory. That is, I mentioned 100. So how much you have to order to increase your inventory level from the 20 to the 100? Yeah, just 100 minus 20. That is 80 unit you have to place order. That's the meaning of a target inventory level. So target inventory level is a kind of showing you that how much you have to increase your inventory level up to the target inventory level. Okay. But again, because we are not able to handle the demand uncertainty by using the when to order under this PDDB system, I have to consider that when I decided the target inventory level. So how come I have to consider the cycle service level and also the lead time. Okay. But in fact, at this time, lead time is not just the lead time plus the review period. Okay, review period is this one. Okay, but anyhow, that I'm going to explain that what is this about. That is, before that, again, just like I did for the continuous DB system, let me show you what happened to the inventory level as time goes on under the period DB system. Okay, so just use a graph as time goes on. I'm going to show you that on-hand inventory. Okay, let's start it with some amount of inventory again. Okay, but at this time again, the demand is uncertain and it's not constant. So that's why the inventory is decreasing as time goes on irregularly. Okay, so this way. Okay, and then before it hit the bottom, okay, suddenly it's time to visit my warehouse. When? It's a P. Let's say it's a P is a review period. P is the review. Previously, I just calculate this by using the EOQ, time between order, okay? And then, but again, even though I place my order at this time, but still, I cannot receive that order product right away. Why? Because again, I'm sorry, the lead time is not 0. Okay, I have to follow lead time to receive that ordered product. So during the lead time, still the inventory is decreasing, and only after the lead time is over, then I can receive that ordered product. But how much? Let's say this is a target inventory level I already set before, even starting this at the time 0. Okay, then how much I have to order? That is from the at this moment when I place order. Okay, I'm going to order up to this one. So in fact, the order amount of this one. But am I going to receive the product right away? As I said, lead time is not a 0, so I have to wait for the lead time to receive this order. Okay. So during the lead time still, the inventory level is decreasing, and only after the lead time is over, I can receive this, the Q1 previously I ordered. And then that I can see my inventory level increase so this far. Okay. So this is the reason why at the first time when I show you Q1, I use just a disconnected line because this does not really happen. Does not really happen. Okay. What really happen is after the lead time is over, I can receive that ordered product. That's the when that I see that actually my inventory level increased by the Q1. So most likely in most cases, that is, the inventory level is not actually does not reach the target inventory when I receive that ordered product. Okay. And then again, time goes on, the inventory level is decreasing, demands happens. Okay. So as time goes on, again, another P, the review period is over. Then it's time to drop by the warehouse again. Okay. And then I find out my inventory level is this much. Then how much I have to order from this one to the target inventory level. This is a Q2. That much I'm going to order. Okay. And then as time goes on, but still I cannot receive that ordered product. I have to wait for the lead time. So during the lead time, my inventory level is still decreasing. Only after the lead time is over, I can receive that the Q1 I previously ordered. Okay, and then time goes on. Okay, So this is what happened to the inventory level under the period review system. Okay. So in this kind of situation, that is, you may see that the time between order 1, it's obvious. Time between order 2, and I didn't draw that. Time between order 3. Am I going to see the time between order 1 and time between order 2 and time between order 3 are the same? Yes, at this time is all same. Okay. Why? Because we have a fixed review period. Okay. And then question is, okay, I already handled that when to order, just a fixed order period by using the EOQ. But what about the target inventory level? Okay. Let's say that here, the mean average demand during the P plus L, the review period plus lead time, is the dP plus L, that is just the P plus L, P plus L multiplied by just the D. I'm using the same formula, that is D is the average demand during a certain time period, okay? And then what about standard? Deviation of demand during the P plus L, that is sigma. Let's say there's a sigma P plus L, that is just the sigma D, and multiply by the P square root of P plus L. Make sure square root cover the P plus L, entire P plus L, okay? Then under this, then I can say the mean, I'm sorry, it's not mean. The demand during the P plus L time, okay, review period plus the lead time, okay? That is that following the normal distribution of the what? The D P plus L, probably I should P plus L, and the sigma P plus L square, okay? So under this, that is the target inventory level. Let's say just is the T, that is just the average demand during the P plus L plus the safety stock, okay? But what about safety stock here? Safety stock is, again, just like what we did on the continuous review system, that is the inverse function of a inverse cumulative standard normal distribution function of the cycle service level and multiplied by sigma P plus L. Okay. So how can I get this? It's the same idea. It's from the standard normalization table. There is a G multiplied by sigma P plus L. Okay. So that way I can calculate the safety stock by adding the average demand during the P plus L. Okay. That I can calculate the target inventory level under the PDDB system. Now, in the end, what about the total system cost? That is, again, if this is a cycle inventory holding cost, ordering cost, and safety stock holding cost. Okay, we have a 3-part, okay, in a year. But on the other hand, when I calculate the cycle inventory holding cost, the way you calculate the cycle inventory holding cost says a Q divided by, do not write down this right now, okay, because it's wrong. Just the order quantity divided by 2, average cycle inventory level multiplied by unit inventory holding cost. But on the other hand, at this time, I cannot set this the way we calculate the cycle inventory holding cost. Why? Because we don't have a fixed Q amount. Okay, every time I press order, Q could be very different. Take a look at the graph I already showed you under the period system. What happened here is the Q1 and Q2 is the same. No, it could be very different. Depends on how much you have in your inventory when you place order. Okay. So basically, if you have a lot of inventory when you place order, then you have to order or just a small amount to reach the target inventory level. But on the other hand, if you find out that the small amount of inventory left over when you place order, then much you have to order a lot to reach the target inventory level. So here is that by implication, that is the amount of your order could be very different, okay, under the period system. So that's why here, go back to the formula to calculate the system cost. When I calculate the cycle inventory holding cost, I cannot specify the order quantity is just one number to calculate the average cycle inventory level. So what should I do? In fact, under the period system, it's very hard to calculate the cycle inventory holding cost. So, but instead, okay, using the order quantity, I'm going to using the what? The demand, every demand during the review period. So I'm going to replace the order quantity with the average demand during the review period. It's just D multiplied by P. Okay, as I just pretend this is order quantity. Okay, and then multiply by unit inventory holding cost. Okay, this is the way I calculate the cycle inventory holding cost under the period review system. And what about ordering cost? Again, we have the same problem. The way you calculate the order frequency in a year, that is a D divided by Q. But again, we don't have a Q here. We have, but Q is different, depends on the when you order. Okay. So that's why instead of it, again, from the previous one, okay, I just got in the implication. So it's instead of order quantity, I just using the average demand during the review period and then multiply by unit ordering cost. And then finally, the safety stock is easy. All I have to safety stock multiplied by H, the unit inventory holding cost. Okay. So again, I assume that either that holding the cycle inventory or safety stock, the cost itself is the same. Okay. I don't differentiate it, the cycle inventory and safety stock in terms of their cost. Okay. So that way I can calculate the total system cost under the period review system. Next one, I'm going to show the example about this continuous review system, period review system, how to decide when to order and how much to order, and finally the total system cost. But I think it's a good time to stop. And let me continue with this that in the next class by showing the example of a continuous review system and period review system. Okay, so that's it for today. See you next time. Bye.